Hello and good morning, everyone. Welcome to our second Tech Talk for the year. We are hosting this for the fifth year, I think, because Women in Data Science started in 2015 from Stanford, and we brought the chapter to Mumbai, the city of Mumbai, in 2018, and so we started another chapter in 2021 for the city of Kerala, for the state of Kerala. So this year we thought, why not join the two forces? And that is why we have Women in Data Science Mumbai and Kerala. And our motto has remained the same for the past 5 years. It's been that we want to inspire, educate, and support data scientists, regardless of your gender, age, wherever you are from, whatever experience you've had before. Data science is a field that anybody can break into, um, regardless of where they are from. So that is one of the reasons why. So I believe personally, I believe in this motto a lot. If you can see it, you can be it, and that is why we want to showcase these different women from different backgrounds working in different companies on data science projects on a day-to-day basis in real life. And that is why we've always tried to bring forth a variety of fields, be it blockchain, be it retail, be it customers, be it payments. So last week, 2 weeks before, we had Akanksha from Google who was talking about payments industry, and today we are honored to have Sravanthi. She is an engineering lead in Google. Um, hi, Sravanthi. So we are really honored to be graced by her presence today. And Shravanti, as a person, is very passionate about teaching people about machine learning. She has more than 15 years of IT experience on various domains: insurance, e commerce, gaming, customer conversation platforms, something that we're going to touch upon today. And she is an engineering lead, so she has a lot of expertise on designing the systems. All of you have been preparing for your system design interviews, building applications using a variety of languages, and machine learning. That's her expertise. So we are really happy to have you here. Thank you for taking out the time to talk to us today. Um, so without any further ado, Shravanti, it's all yours. You could go ahead and share.
Good morning, everyone. Hope you're all having a great time. Let me share the screen. Julian, can you see the screen?
Yes, yes, it's visible. Yes.
Thank you, Julian, for the introduction and a very good morning. Today, we're going to discuss about customer interactions and how we are doing that in machine learning, how machine learning is helping us to derive what are the different customer interactions, like how machine learning is being used in improvising the customer interactions. So today's topic is mainly going to be on that. Myself, I'm Sravanthi, working as a technical lead in Google at Conversation Platform. So let's get into the discussions. First, let's understand what is a customer interaction. Customer interaction is nothing but a communication that happens between a customer and a business. Why do we need a customer interaction? We need a customer interaction to have quick answers to our queries. The queries can be like, what is my balance? I need a new information on a product that is going to be launched. And it can also be to perform a certain tasks. The task can be like returning an item, canceling a subscription, or transferring an amount. It can also be like getting a feedback on particular product. So these are the ways we need by customer interaction. How does a business support these customer interactions? The business support these customer interactions via a call center or a contact center. Though call center and the contact centers are used interchangeably, there is a lot of difference between them. Call centers are primarily focused on voice-based communications, whereas contact centers are based on the multi-channels. These channels can include a phone conversation, a chat conversation, email-based conversation, a messaging-based conversation. It can also be like a video conferencing or through a social media. So when a business is supporting the customer interactions with multiple channels, then we call it as a contact center. Let's take an example and see how it actually works. For suppose a customer is having an issue with the payment transfer. So the customer can reach out to the business via chat saying that I'm not able to do the payment transfer based on the conversation that happened. If the responses are not done, if the customer is not getting enough responses on the chat communication, he can go back to the phone conversation and then get the things resolved. But the problem with the multi-channel is they are mostly siloed. That means that the communication that happens on one particular channel is not available at the other channels. So these days, systems are doing, businesses are moving towards omni-channel. So in the omni-channel system, what happens is the data is shared across the system. So in the same example that we have discussed, where a customer is having an issue with the payments, when a customer is talking on the chat, he might be seeing what are the different issues he might be getting based on the discussions. The call can be that emailing can be transferred to an agent. When an agent receives a call, the agent will have the information about the entire context. He need not even go back to the customer and ask different questions like repeated to the same questions. What is your number? What is your account number? All these details need not be asked. So in an omni-channel, the responses are very fast and we can have good customer satisfaction. Now that we know that businesses uses these particular multi-channels to support the customers, but do we really need an representative from the business to address all kind of queries? No, right? There are some repetitive tasks like a user wants to know the balance. It's a repetitive task for an agent to look into the account details and get these details done for every user. Now, there are something like if a customer wants to know about a new product, uh, a customer calling the representative and representative talking about the same details over and again. So these are some of the tasks which can be automated. So the way businesses does this automation is one of them is a chatbot. Chatbots are nothing but an AI based software programs which are used to do some kind of work like making a reservation or getting an date from an booking. And so we can use chatbot for many use cases. One of them is like making a reservation. The other one, if you wanted to mark a date important in your calendar, we can also do that. So the most frequent model that we use in a bot is a chatbot. So what are chatbots? These chatbots are computer programs that interact with people in a way that mimics human interactions to some degree. What are the advantages that we can get with a chatbot? Humans can focus on more interesting issues, more complex issues. The chatbots are available 24 by 7. They can serve the customers whenever they have whenever they have an issue. They can provide a great content, and they are like having more of the knowledge base. But the traditional chatbots are very specific to the domains. So they are constrained with those domains, and they are mostly based on the rule-based applications. For suppose if it is if there is a chatbot for the payments, so the chatbot can only understand few things on a payment like credit card details, amount, dates. So it can recognize only the few of the fields and then it responds. Now let's see what are the different examples that we have it in chatbot. The first example that we have it over here is from the HDFC Bank. So have you ever tried logging to an HDFC Bank? If not, just go and check it out. There is an bot called Eva. What it does is you need not contact the agents or anything. You can use it to do the pre-processing of the loans. So the bot helps us to do the pre-processing of the loans. Similarly, there are use cases on CNN where once you log into the CNN, you can see that what are the different top stories, any specific stories that are assigned to you, interested in you. All these can be given by the chatbot assistants. You need not talk to a particular person to get it done. Then we have the Google Assistants. So if I wanted to know the price of a particular product on an eBay, I can just call the Google Assistant, find out, can you let me what is the price of this particular product? And Google Assistant responds to us with those details. These are the couple of examples with the chatbot. The other way through which businesses try to automate the processes is the IVR. IVRs are nothing but an interactive voice response systems. They are an automated phone features. What they do is when a caller wants to contact to a business, the first thing is they will dial to a toll-free number. When they dial to the phone toll-free number, the first thing that interacts with the customer is a IVR system. What it does is it takes based on, it tries to read the data from the keypad. For suppose we might have seen examples from the whenever we are having a mobile network issues or some banking issues, we try to reach to a customer using a free contact toll-free number. So the first thing what happens when we try to reach to the toll-free number is it asks us like what is the language, what is your preferred language, choose one for these, choose two these, choose three for the other languages, and then based on our option selected, it takes drill downs to the further points like whether it is a payment issue, whether it is a billing issue, or whether a new product information. So that's a typical IVR flow. What it does, it takes actions based on the answers of the caller through the telephone pad and then do a response. What are the advantages of having an IVR system? They support busy times and then disaster recovery. They improve the customer journey a lot because before reaching to the agent itself, the IVR system can provide answers to those queries. Like if you wanted to change the password pin, right? We don't need to talk to an agent. This IVR system will helps us to do the changing of the password. It asks certain questions, and once we answer those questions, and then IVR system will be able to help us to get the solution. And it also frees the representatives from doing these repetitive tasks. So these are the couple of advantages that we have with an IVR system. Now a business has multiple channels through which it can communicate. It has certain automated process like chatbot and traditional IVR systems. Is this sufficient to run an customer service application? Let's see what are the what are the problems that we have with our existing IVR system, right? In the existing IVR systems, what we have is the higher transfer rates. Um, when you call to an IVR system, the call says that can you just be on hold? It will be transferred. It will be handled by the next team. So there would be a lot of high transfer rates. Then at times with the IVR system, there is no way the customer can make out what he wants it. Some of the IVR systems have complex menus. They take it to multiple options. And then there would be a lot of, if you wanted to reach out to an agent on the IVR system, what it does, they keep us in a repetitive hold or music. Then since the IVR systems are based on in pre-recordings, if they have the poor quality, then we cannot hear them properly. Then the last one is the personalization. What I mean by personalization is whether the person X calls the customer, whether the person Y calls to the customer, the IVR systems has the same way of responding in, right? They do not understand the customer who the person is, what they wanted to know, but it gives the standard template saying that you have to go through these all the options. So these are the couple of issues with the existing systems. Now, based on what we have seen so far, there are a lot of issues, even though the customer services system supports chatbots or IVR systems. So what we have is there are a lot of machine learning opportunities over here. The first one is the context-driven interactions. What do we mean by context-driven interactions? For an example, let's see that a user wants to know about transferring the details, right? He had an issue, now he wants to find out, reached out to the business asking help to complete the transaction. The first thing when an IVR system does is it'll ask for the options, and then it will try, we have to navigate to it to a particular option and then give the context. But as soon as the customer calls the toll-free number, assume that we have a system where it asks what is the problem, and then the customer says that I'm having an issue with my transaction, I'm not able to do my payments. So based on the context that is part of the that is there in the message. The systems can read those messages and then uh, take a proper action, like redirecting it to an appropriate agent or responding the uh, query with a proper message. So these are context driven interactions that can be done using machine learning. The other one is the agent assistant. Now uh, there are agents in our system who are the representatives for the business. Let's assume that the agents are dealing with multiple issues, and they, what we see it when an agent is trying to make the conversation with the customer, there's a lot of crosstalk. That is, both the parties are talking at the same time. Or there are a lot of silence. What do we mean by silence? There is a lot of pause between an agent and an customer. So we can use machine learning to identify the patterns, like how the crosstalk is happening. Is there any silence in that? So we can help agents. We can teach them. We can coach them based on the way they are trying speaking and all, and we can help agents to become smarter. So that is what agent assistant means. Then we can do customer assistance. What is customer assistant? We can help our customers. um, if you know what is the context behind the what customer is asking for, we can use that and we can provide better solutions for the customer. So we will go and see in detail how actually machine learning does all of these. Then we have the audio quality. For suppose a customer is talking over the phone and the customer says that your voice is not, I'm not able to hear you. There's a lot of background noise, and so we can use machine learning to identify uh, this text in the audio, saying that certain patterns. We can try to classify these patterns, identify the topic, saying that voice issue, network breakage and all, and then we can tell there are certain, we can identify what is the quality of an audio using these machine learning techniques. Then what we have is the forecasting. uh, the example for this one is the we know, like when we are trying to join to a college, what we see is like initial period, the joining period, where we have a lot of queries and lot of questions, right? But as the time moves on, we will not be having those many questions. There will not be so many people who reach out to the colleges to get to know the information about. What machine learning can do is it can identify, based on the past data, it can identify what they are the different forecastings that we can do it, and it can predict, okay, these are the number of agents required, and these are the specific areas where we need to focus. So all this can be done using machine learning. Then we have intelligent call routing. So what does intelligent call routing does? Based on the context from the caller, it tries to map to a particular agent, right? So the agents can have certain skills. Not every agent is an expert in everything. So each agent can have certain skills. So based on their skill level, based on the context from the calls, what machine learning can do is it can redirect it to a right agent. So these are the couple of use cases in customer service where machine learning can help. Let's see how context driven interactions happen in the customer service using machine learning. The way context driven interactions happens is through an conversational AI. So conversational AI, it's also known as conversational artificial intelligence, is a set of technologies that enables computers to simulate real conversations. It is a technology that enables computers to recognize multiple human languages. It processes the words that are being said and determine how to respond to in a more human like way possible. So it tries to grasp what is there in the uh, message that is being sent. It will try to process the words, and then it will try to respond, give an appropriate answer. For the example that is given over here is like, if you wanted to know what is the balance, right? The system can understand what the customer is saying, what is the balance. It will use this artificial intelligence, machine learning, and deep learning techniques, and then it can say, your current balance is $1,000. So what is artificial intelligence? Artificial intelligence is a science of getting machines to mimic the human behavior. What is machine learning? Machine learning is a subset of artificial intelligence that can self-learn based on certain algorithms. What is deep learning? Deep learning is a subset of the machine learning. It is inspired by the human brain filters. We will see how actually machine learning does and how actually deep learning helps in the conversational AI. Let's move on. So what is machine learning? Let's take an example and try to understand what machine learning is. But suppose if you wanted to build a system where it can predict the house price. In a traditional rule-based system, what we do is we try to get certain parameters, right? Like what is the square feet, what is the number of rooms that we have it, number of bathrooms we have it, whether it is a fully furnished. There are certain criteria through which we wanted to predict the house price. So what we do, we come up with a, if it is a rule-based system, what we say, if there are 3 bedrooms and some amenities, this is the price in this particular location. So if there are, so the number of combinations, if there are the combinations are less, what we can do it, we can directly get it, build a small system and then predict what is the price. But let's assume that we have hundreds of parameters. Now if you have hundreds of parameters, coming up with a common solution is very difficult, right? Writing those many rules and predicting it, it would be tedious. We cannot get those answers. So where machine learning helps over here is, for the given input data, it tries to extract the features. What we meant by features are nothing like in our use case. These can be like bedroom size, what amenities, so whether we have the security or any other features that we wanted to use to come up with the prediction is called a feature. Like any of these parameters that we wanted to use to come up with the prediction is called a feature. So we can use a trained ML model and then predict it. But how is this trained ML model built? Now for building a trained ML model, we need lot of data. Now this data can be coming from multiple places, right? You can have a Google Sheet from where we can get the messages. You can have a database where the data can reside, or it can be available in web. So certain people post their details on some website saying that these are the bedrooms, these are the things, and this is my price. Certain people maintain their own databases to have those data. Certain people maintain in Excel sheet. Now, these data is taken from multiple sources and the data will be sent for the cleaning and pre-processing. Now, the database can have one particular format like a flat number, right? Now, the sheet can say house number. So there would be, the namings might be different for each and every system. So what the first step in there, machine learning is the cleaning and pre-processing of those messages. So we take the machine learning model, we take the data, we do the cleaning and pre-processing, and then we extract the features. What do we mean by extracting the features? Now there is data, properties can be containing like 20 to 30 or more than 100 parameters. But what are the required parameters that we want, right? So we have to tell the system like what are the features that we need to extract, and then we have to train the model. Now while training the model, what happens is, there are certain machine learning algorithms like linear regression, logistic regression, SVM, decision trees. There are a couple of machine learning algorithms which we can use it and then train it. While training it, for suppose there is like 1 million rows, like 1 million data that we have it with us now. What we do is we would, let's assume in our case, like we wanted to see how the system is predicting, right? Whether it is predicting accurately or not. So for that, what we do is we keep certain amount of data for testing. So let's assume that we have taken 90% of the data for training and kept 10% for testing. Now, we using this 90% of the data and using these machine learning algorithms, we train our model. Now, once the model has been trained, we will use the testing data to compare it. Like we will take the first instance and we will try to compare what is the result. In the training in the phase, the value might be predicting like for 3 bedrooms and then with X, with two amenities, the price is coming as 10,000. Whereas in the testing data, it says that for 3 bedrooms and two amenities, the pricing is like 15,000. So there is a difference between these two, like 10,000 and 15,000, right? So these two values would be compared, and with that, now we see that there is a huge difference. Again, we will tune our model because the accuracy is not met. We will try to identify and come up with an appropriate accuracy. Let's assume that if the system is built in such a way that if it is 90% accurate, then that means that the system is doing well. Now we take this, once the testing and the once accuracy has been obtained, proper accuracy has been obtained, we take the model and then we deploy it. Now for any incoming request, let's assume that the customer is filling up a form and then the application is trying to send the data to a trained model. So it takes from the input data, it extracts the features, whatever the feature extraction that we used in our training model, it extracts the same number of features from the input data, and then it would be sent to the trained model, and the trained model would do the prediction. So in this particular thing, in nowhere we are telling the system what are the different parameters, I mean, how the different parameters should uh, come, right? The system, what it is doing, it is using the data, it is seeing how based on the, it tries to correlate between different parameters. The system itself will do a self-learn, correlate between different parameters, and then try to respond. So that's how machine learning works. It tries to learn by itself and then give a proper prediction. Okay, now we have machine learning, but why do we need deep learning, right? Deep learning is an advanced form of machine learning which comes in handy when the data is like unstructured. But suppose uh, you have an image, right? Now you wanted to say whether it is a uh, dog or not. What we do is we have to identify what are the features for the traditional machine learning model. What we have to do, we have to identify the features and then we have to give it to one of the machine learning algorithms, and using that machine learning algorithms, what it does, it predicts whether it is a dog or not. Now in the deep learning, what it does is there is the feature extraction, like how, what are the different pieces that we need to consider while taking a dog image and then do the classification, right? So everything is combined under one sector. Deep learning uses these artificial neural networks to come up with a solution. There are certain algorithms, there are certain deep learning models that exist in the system. Some of them are convolutional neural networks, which is used for image processing. Then we have recurrent RNN, which is a recurrent neural network. Then we have LSTM, that is long short term memory. These are the couple of deep learning models that we have it right now. How actually this deep learning is done is based on an artificial neural networks. So what do we mean by artificial neural networks? Um, Now let's take our example like image, right? Well, when how do we represent image? Now image is generally represented in the in pixels, and what are the different types of pixels it has? It like red, blue, green, right? These are the combinations. Any color that we have it in our system can be represented a combination of red, blue, green. Now the, you can take the image and from you can see what is the color for red, what is the color for blue, what is for color for green. It would take all these details in numerical format, and then we can send these details to an neural network. So neural network has an input layer, has an output layer. Our output layer here is a prediction whether it is a dog or not. Our input layer is an image which will be converted into some numerical vector and then sent to the system. Then we have the hidden layers. So what these hidden layers does is it tries to identify what are the different weights that we have it in the system, and then come up with an, this hidden layer is like not visible to us, so the system automatically takes care of that and comes up with a particular solution. Now we have seen what is an machine learning, what is deep learning, and let's see how the conversational AI uses these machine learning, deep learning technologies to do an more robust way of communicating with the users. Now, a customer can have either a voice-based communication or he can have a text-based communication. When a user is having a voice-based communications, there is a speech-to-text conversation model. What it does is like it would take the audio form that we have it and converts into a text format. Now, once the text format is available, then it goes to the natural language understanding module. So what this natural language understanding module does is it tries to find out what is the intent behind this particular text. Like, for suppose the example is I want to play, right? In this play I want to play cricket, is an example. Now in this module what natural language understanding does is it tries to identify cricket, it is a noun, the playing is a verb, and then it tries to identify what is an intent behind the user, what are different entities associated with user, and then come up with a more contextual value to the question what customer is asking for. Then once you have the natural language understanding, it goes to the natural language generation flow. What is this natural language generation flow? It takes the unstructured data that is generated from the natural language understanding and it converts the text into a human readable format, and then output to the chatbot or a system where we are doing a message based conversations. Now what if it is based on a voice based conversation, right? um, like how we have a speech to text module, we also have an module for text to speech conversation. In the text to speech conversation, what happens is whatever the human readable language that has been generated by the NLG, it takes those details and it converts into an audio waveform and then send it to the chatbot systems which are based on speech. So this is how the entire conversational AI works. Um, it has different modules to do it. One is this automatic speech recognition, and then one is the natural language understanding module, then the natural language generation, then there is a text to speech module which converts the text from the voice. Now let's dive in a little bit and see how these modules are actually um, does the conversations. So what is ASR? ASRs are nothing but an automatic speech recognition. What it does, it translates the spoken words into text. Are there any examples that we have it in right now for, in ASR systems? Yeah, if you go have been to YouTube and if you have seen the closed captioning, YouTube has this closed captioning which is based on an ASR. There's voicemail transcriptions like the conversations that happens on an audio, they get converted into an text format. So that is also another example of this ASR. Why is ASR difficult? There are different, each person is different from the other, right? Some users try to speak it in a continuous words. Some tries to speak it in an isolated words. Uh, Now there can be other factors involving into it, like environment, like you can have a background noise when a person is speaking. Then there are like certain characteristics, like the accent in which the speaker is speaking. Then we have like an whether the speaker is an based on whether how the conversation is happening between an adult or how the conversation is happening between a child. So there are different speaker characteristics that comes when an audio form is waveform is generated. Now there can be certain language constraints, like the way we speak in English differs from the way you speak in Hindi. So these are the couple of issues right now we have with ASR. So that's why it is very difficult to come up with a proper way to design this automatic speech recognition system. How an ASR works? So what it does is it takes the raw audio form, the waveform that we have it, and then it extracts certain features. The audio form is generally it's an analog data, but whereas our computers they can only understand the digital data. So there should be a way to convert this audio data into a digital data and then use certain machine learning techniques to convert into a text. So there are like existing modules like MFCC and DWT. These are the two techniques which are being used right now to extract these features. So at the end of the feature extraction, we get a numerical representation of our audio form. Once we get the numerical representation of the audio form, then what we have is a decoder. What this decoder does is like it uses an echoistic model. So what is an echoistic model? Um, uh, in an example, like I want to play cricket, uh, we have these words like want, play, cricket, right? Now, the echoistic model will try to understand the phonemes in a particular language. For example, this sentence that we have spoken, it's in English format. Now in English, if you're writing a sentence, then each we can represent the words within the sentence with like 26 letters, like that. Echoistic model is a sound, the way we sound. So every word in English has one phoneme associated with it. So what is a phoneme? It's like a sound. How how we have letters for writing a language. Phonemes are for the sound systems. Like for suppose we are saying like want, the, way. So there are certain identifications. So in English there are like 44 phonemes which can be mapped every sound into this one of these phonemes. So echoistic models will take the feature extraction modules, and then it will build what are the different phonemes that we have it in that particular. It will try to identify the phonemes. Once the what are the how is this echoistic model built? So this echoistic model is built based on there are some techniques through which we can build this echoistic model. One is an HMM, it is a hidden Markov model. There are other techniques like GMM, or you can use neural networks. These days, many companies are using neural networks to come up with a better acoustic model to identify the phonemes. So once the phonemes are identified, then comes the lexicon. What it does is the lexicon groups the words. It will try to group the what are the different words that we have it using these phonemes, and then there is this language module. What it does is it will try to add the rules like grammatical rules and everything. So the decoder uses this acoustic model, lexicon, and the language model, and then converts and write the data into an text, which is nothing but a transcript. So a typical ASR has all these flows like taking an audio wave, which is an analog format, and then converting it to a text format. Now, the second piece in the conversational AI is the natural language understanding. So, natural language understanding is a subfield of natural language processing concerned with teaching computers to come up with an contextual meanings of an human communication. How does it do it? Like in the example, I want to play a cricket. It will try to understand play is a verb. It's an action associated with it, and then it will try to find out the entities like cricket. Cricket is a noun. It's an entity, and then based on these intents and entities, it will try to come up with a contextual meaning, and then give an answer to the questions. Like I want to play cricket, so it will try to understand that the question being asked here is like an I want to play cricket. It will try to find the intent and then capture the results. Based on that, the subsystems can take an appropriate action. Where does this NLU application helps in? The NLU applications mostly helps in like text categorization and classification. Now, I am from an I am a business where I am doing credit payments, right? My system deals with the payments. Now, I wanted to based on our incoming calls, I wanted to map them saying that whether it is a issue with a credit card, whether it is a issue with a debit card. So NLU applications can read these text messages that is obtained using this ASR, and then it can convert these and we can do a proper classification of these like it belongs to the bucket A, which is an credit card. Now then it belongs to the bucket B. It's an issue with the debit card. The second application where it is being used is the automatic summarizations. Like you have a long book, you have a long story. Now we wanted to just do the summary of that particular book. So what we can do is we can use the NLU modules. We can read the text within it, understand, parse the text, understand what the customer is trying to say, and come up with a summary about what the topic is about. So that is another use case where the NLU applications are being used. Then we have the voice-based applications, voice bot, the one which we have seen in the conversational AI. There is nothing but a voice bot where the customer tries to say something, it tries to, the SR module converts the data, and from there, we can find the intent, and based on the intent we can find what is an appropriate action. Once we have an appropriate action, it can give to the subsystems, and the subsystems can respond to the user. The other one is can be using it question answering, like if it is a chatbot application, it is based on the text. We can read the questions and then it can answer it. The another application where it is used is in semantic parsing. Semantic parsing is to identify the grammar, whether it has have proper grammar or not. NLU applications are widely used over there. The in the customer applications, the other another place where it is used is the sentiment analysis. What is sentiment analysis? Um, Based on the conversation that we have with an representative, you can either tell whether the conversation is either positive or a negative, or you can give a grade scale between 1 to 5, saying that the conversation is and how the conversation flow is happening. So by looking at the intent and the emotions behind how the conversations are happening, we can identify the sentiment of the particular call. We can identify, associate them whether if it is a positive sentiment or a negative sentiment. So these are the couple of applications where the NLU is being used. In our conversational AI, the third piece that we have is the natural language generation. Natural language generation is a subcategory of the natural language processing. It is a software process that automatically transforms the structured data into human readable text. Now, the NLU, what we have done, uh, we have taken the text which is coming from the ASR. Now we have used that, and then we have tried finding out the intent. Now we have to respond. The system has to respond to the user. What it does is it takes the intent entities and everything from there. It does content determination. It identifies what is the content that is being said. For an example, if you're trying to find the natural language generation for a football match, right? It tries to identify that the content is for the football. Then the interested entities are like number of matches or like the goals. It will try to get the content based on this particular content determination module. Once we have the content has been identified, then it has a data interpretation. Now, based on the content that it has obtained, it will start interpreting the data. Now, what it does is, once the interpretation has been identified, then it does a document planning. So, in the document planning, what happens is like the structure of the data, it will try to identify the structure of the data. Then the next piece that comes in an analogy is the sentence aggregation. It will try to find out the words that they are required in that particular, how to respond it. Then comes the grammaticalization. Grammaticalization means that it will try to apply the language rules and everything. And then the last module comes is the language implementation, in which language it wanted to respond. So these are the steps that goes into an analogy. Using all these modules, an NLG will be able to predict in a more human readable text. Where are these NLG applications being used right now to automate? Like they are used in personalization, then they are used in narrating report, they're used in creating the content text scale. The one which we are discussing right now is a conversational AI use case where it used to where they are used to respond to a particular action. Now, if it is a voice-based communication, the text that has been generated has to be converted into a speech. So this module is called TTS. It is also known as text to speech or the speech synthesizer. There are multiple names which people call it. So what does text to speech does is it generates the speech based on the text. How it works? So it takes the text as an input. Now the text is converted to words. When a customer says 1943, right? Now the 1943, it can be a number or it can be an year. All right. The way we say year and the way you just say a number, it's completely different. Uh, Now there are modules which would use acoustic modules and all are there, which takes this text and then convert into the proper words, because not everything can be represented in English. In this case, our example is in English, so there we have to understand the intent behind the words that are being used. We'll try to get the context. Once the words are identified, the words are converted to a phonemes. Um, like we discussed earlier. So the words are every word can be represented in a phoneme. So the words are then converted to into a phoneme, and then once we have the words converted into a phoneme, then the phonemes are converted into a sound. So in the text to speech modules, what we have is a text which gets converted into words, and then from the words it gets converted into a phonemes, and from the phonemes it gets converted into a sound. So what are different applications that we have where this text-to-speech is applicable? This personal virtual assistant like Siri, Alexa, or Google Assistant. So they use this text-to-speech module to do the conversations. The other place where it is being used, like you can have our own audiobook or a podcast. Instead of going through the for suppose there is a book which we would like to make it as an audio, right? So these text to speech modules can use the um, these applications can use this text to speech module which can read the text data and then convert into an audio form. There are websites, like not everybody has understanding of the literature, right? When we go to the website, not everybody can read through the websites or understand what the websites are doing. So there are certain websites which support speech enabled uh, services. And then what we have is the other use cases where it is helpful is the to help the disabled people, like the people who cannot see. The text to speech modules can help them to understand and things in a better way. Then there are tools to support literacy, like old languages and all, right? If you it is hard to maintain them, so we can use this text to speech module to convert into a proper literacy and then save it. These are a couple of examples that we have it in a and with the text to speech. There can be more modules over here. Now, what we have seen how ASR works. What are the different modules in conversational AI? Now, let's see how these different modules will provide insights in the customer service applications. Uh, so it can do process compliance. What do we mean by process compliance? We can do customer authentication using that. It can read the details of when a customer is talking. It can fetch those details and then it can do an authenticate the particular user. Now, the other one we can do is offer CSAT survey. What is CSAT survey? Is a customer satisfaction survey. Based on the type of the customer we are dealing with, we can do a personalized CSAT survey for the particular customer instead of following a standard template. We can use for correcting the brand. Now, there are other use cases where it can be useful. These are policy and regulator compliance. Like when a conversation is happening, the first thing generally people ask is for the recording consent. Like, can I take your consent to record your audio? Like, suppose if the agent has forgot to ask for the recording consent, a system can send an alert message saying that by looking at the content in that audio, it can say that you haven't asked for an recording consent, or if the customer is sharing a confidential information like passwords, like account details, social security numbers, on all these details the customer, if an agent is asking for and these details, the system can monitor, identify the customer is asking for these particular kind of words, and then alert the user, alert the agent saying that you're asking confidential information which you're not supposed to ask it. It can also use to do a professional conduct. When we say professional conduct, what we mean was like, if there are some forbidden words which are being used, if the customer or the agent is displaying an negative sentiment, it can alert agent saying that the customer is trying to speak in a negative sentence, use this and then improve the communication. Then it can also useful the in the operational insights, like we can understand we, based on using all these techniques, we can identify what are the different topics that are being discussed, like what is the call that is being done, what are the different what is the reason for having these calls, what impacts the customer, so what is the most impacted issue with the customer, uh, how the call transfers are happening, how the escalations are coming up. Like we can get all these insights based on the transcripts that we have, like identify the reasons behind these transfers and escalations, and take we can improve ourselves. Then it also helps in improving lead conversation and sales. What we can use it, we can use these once we have the text that has been obtained using the ASR module, we can see what and how the conversation is happening, like if there are long pauses in the conversation, or if there are like too much of noise in the conversation, that there are back and forth communications that are happening, or if the customer is uh, mentioning about a competitor name, and then how the salesperson is responding to these competitors when someone is asking for a particular competitors, how the system is doing it. So it can try to identify these details and help uh, salespeople to do better, to become smarter. The other place where we can use these modules is in the audio quality. So what we can do it, we can identify the take the text, and then we can identify what are all the audio problems that we have it. We can listen to the specific words like I cannot hear you, network connectivity problem. So we can use all these particular text that is obtained from the ASR module, and then we can say that whether the audio quality is good or bad. So these are the couple of insights which can be generated based on the based on these modules like natural language understanding, natural language generation, and then ASR. Now, who uses this all these analysis in the customer service applications? So in customer service applications, we have different personas. Generally, most of the times what we think would be there, we have an agent who is an representative for a business who handles the calls, and there are customers who are the ones who wanted to know certain information, or like, but there are different personas that are available in a customer service application. So one of them is a consumer support agent. The agent, what he wants to do it, he wants to improve his uh, resolving customer support needs, right? He wants to maintain a high CSAT score. Then we have an supervisor or the team lead who wants to understand what are the, he wants to track the agents, and I see how the agents are really doing good, so that what, so that he can coach agents and improve the performance. Then we have the sales representatives. Sales representatives and the customer support agents are different altogether. They are different sets where the customer support team understands the queries, like um, whereas sales representatives, they try to reach out to the customers. So they wanted to promote their product so that customers can take their businesses. They can. So what the salespeople wanted, they wanted to improve their sales performance so that they can increase their sales commission. Then we have the quality assurance analyst. What they wanted to do, they wanted to review and track agent quality time, like how is the, what is the call duration, um, how long is the call is happening. So so they wanted to do it so that they can increase the number of calls that can be taken in the system. Then we have product specialists, like they wanted to review the real time life consumer interactions, like what is the customer really asking for, so that they can gain product insights and improve the understanding for the customer sentiment. Then we have the product manager who wants to know how the product is being consumed so that they can drive product development decisions and roadmaps. These are certain personas that we have it in the customer service applications. These are not these are not the only personas. There can be more depending upon the type of the customer service application the business supports it. Okay, now we have the insights. Now we have the machine learning models which can generate the insights um, so that the business can run it in a smooth way. But are there any issues with this? Like, are there any security and privacy concerns with more, with these voice recordings? Yes, when a voice is being is spoken, right? When someone is speaking on a particular voice, what all different things that you can get it from the voice? We can identify what is the pitch, and we can get certain pitch voice characteristic, like how loud is the conversation, what is the pitch of the conversation. Then we have certain speech characteristic, what is the pronunciation, how the customer is doing the pronunciation, what is an accent, what is the speech tempo. There are certain non-speech sounds that we can identify based on the voice recordings. Those are like whether the customer is laughing, whether he's a cough, uh, whether there are any sneezes, whether the customer is crying. So we can identify certain non-speech human sounds. Then there are like certain background sounds that we have it, whether it is a vehicle sound, whether it is an eating sound, whether it is a media sound. So just by looking at the voice, we can observe these particular characteristics, and from these characteristics, we can inference about the user, like what is his physical health, what is the gender, what is his mental conditions, are there any issues, what are the moods and emotions. What is the behind intention behind calling body measures, right? Just by looking at the voice recordings, uh, a, a business can get info lot of detail. So because of this particular reason, there are limitations on voice recordings. We cannot do a lot of machine learning models on the uh, voice recordings. There are like companies imposes rules saying that you can only store like it maybe a 1 week of data, maybe only 2 weeks of data, whatever you wanted to do it in, do it in those days. So there are many more concerns because voice recordings have this voice fingerprinting, where you can identify a user based on certain characteristics. So if there are these issues, then how are the systems able to generate insights, right? When we have, there are a lot of security and privacy concerns, how are system generating those insights? So when we talk about privacy, the privacy has certain details like personal identification information. So these personal identification information are like social security numbers, email IDs, which can directly tell the person. We can directly use these particular details to identify the numbers. Then we have quasi identifiers. Quasi identifiers, we cannot infer the person directly using uh, these entities, but what we can use it, right? Um an example for this one is like, I can use the geographical location, I can use the gender, and I can use the age. So based on these three details, I can identify who the person is. So by using single entities, there is no way we can infer the who the person is. But by grouping certain group of entities, we can identify what who the person really is. So these are called quasi identifiers. Then there are sensitive attributes in a conversation. It can be like an salary, health conditions. So these are certain characteristics which are very specific to the user and which are very sensitive information, right? Then there are these non-sensitive attributes, like which does not fall into these three categories, like country, right? When I say I belong to India, what we can infer, a person belongs to India, but he cannot identify nothing more than that, right? These are non-sensitive attributes. We have personal identification number, quasi-identifiers, and then sensitive attribute. So there are certain privacy models which helps us to get rid of these particular details. So how is it done? One way is the k anonymity. So what it does, it says that beyond a particular threshold, uh, we cannot narrow down information about people beyond a particular threshold. So how it is done is it uses techniques called purging. Like if it is having an PII information, it will just replace with a star. It will not give the so that nobody know, identifies the person using with an email or an social security number. The other one is the generalization. So if there are categories which says that person with particular age is having an heart disease issues, what it does is it will change the age and then it will try to replace it with uh, ranges. Or if it is like an you're talking about the percentage of the people that has been passed, right? Instead of taking the percentages, it can replace with a categorical values, and from the discrete values it can move it to a categorical values like passed and all. So these are certain techniques which are being used to come up with an masking of the actual properties so that we can generate the insight. There are other models also like L diversity and T closeness, which closely works on these privacy modules. Now, with these modules in place and with these purging and generalization, still there are chances that we can identify a particular customer. So these days, this differential privacy is taking is being used a lot. What this differential privacy does is it lets you gain insights from the larger data. So what it does, it tries to introduce noise. For suppose in this uh, particular image, what we have from the first image, what we have seen that we can identify a person. Now, what differential privacy does is it tries to add the noise of the image, and then if you see the last picture over here, you will not be able to identify the person, but you know certain details of it, but you will not be able to identify the what is the person. And so we can use the differential privacy helps us to anomalize certain characteristics of the data. So these are the couple of ways through which an a system is trying to come up with an data. So now we have seen how the customer applications services are built. Now how ML is being used in that particular customer service applications. Then we have seen what are the trade-offs with the security and privacy concern. What are the some of the modules that we have it for how we can control the person's characteristics by using certain privacy modules. So all these put together, a customer service application can be built to improvise the customers, to give better quality for the customers, and then provide the insights, required insights without compromising on the privacy. Um, Arjun,
Yes.
that's all I have for today. Do you guys have any
That.
questions?
So that was first of all a lot, and thank you so much. It was very detailed, but I really love the patience that you had in breaking down every single jargon of the AI world. You spoke slowly, and that was really nice. So yes, there are a few questions.
Okay.
I hope you have the time to answer them.
Yes, yes, yes. Let's go with it.
So Anshul has asked, "Hello Shravanthi, as compared to English language, when conversations are in regional languages, are there any extra steps or algorithms used to build those models?"
Yes, right. When we have these acoustic modules and the language modules, right? When we are trying to build those modules, so those modules can look for the informations and then we can add the grammatical rules and do it. So we can use those modules and then come up with an build proper modules for the use cases.
Awesome. Okay. So I think regarding models, there was one question like this. I think you had mentioned in one stream that there are a few of these SVMs, RNNs, or LSTMs used. Which of these algorithms works the best, or is it use case dependent?
Each one has its own it's based on the use case. Like if you wanted to have a decision trees, it's like you wanted to come up with a particular solution, like it's like an if and yes conditions, like then we have this RNNs. What RNNs does is it uses the previous data state, like just by knowing the previous state it tries to get the results. It will not be looking for the past data. It will just look for one state behind that and then tries to model and give it. Then we have this LSTMs. What LSTMs does is it is more to the RNN. Instead of looking just for one particular reference, it tries to look for an long sentences. Like it will try to capture the intents, like from not just an immediate one. Based on it will try to group from the past data, identify what are the different sequence of the words that we needed, and how do we do it. Then we have this Markov chains. Markov chains work based on the probability. What it says, like is for a state, today if I wanted to predict something, it only depends upon previous state, and it's a what is the probability of this particular state happening. So based on the requirement, type of chatbot we are trying to build it, so these use cases come into the picture.
Got
We
it,
cannot
got
say
it.
one does the better, but based
Better.
on the use case that we are trying to solve it, these models help over there.
Yes, thank you. Thank you for that. So, when you're working on a daily basis, is there any particular way that you do user research when you make these chatbots to make it intuitive? Because the example here that's mentioned is Google Assistant waits for us to type or speak, but there are some chatbots like you had mentioned, Alexa for Axis Bank and Eva for HDFC Bank. They have these set of phrases to choose from, like what's
Hmm.
your problem today, then there'll be ABCD, you can click on those.
Hmm.
So but then assistant doesn't do that. So is there a certain set of user research that is there behind it to make it more intuitive?
There are researches that are happening in Google, but I'm not part of this Google Assistant team, so I do not have the enough information over there. But there are research teams who actually sees how they can improvise these communications. There are a lot is happening. There is a lot of research happening in Google itself to identify like how we can improve the customer experience.
Got it. For someone who's just starting, would it be best to start building a chatbot that which can pass text or audio? How different is the processing for each and difficulty level?
Like we discussed, right? If it is talking about an audio, audio has lot of uh, uh, things that we need to consider it. Like it has characteristics, what is the environment. We have to clear the noise from the particular audio frame. Then we have to understand the accent, how the word is spoken. Then you have to find out the intent behind, like what is the user. So there are a lot of difficulties with the audio, but with the text, we can skip one level, right? We do not need an SR system which deals with that particular module. But to start with, text is a easiest one when compared to audio, because audio has its own challenges. Like we need a module to read the text and then do a conversion. Again, we have to have another module which again reads the text and converts back to an audio form.
Thank you for that. I think this is the final question. Could you recommend any book or course that you took initially, maybe, to understand how to build conversational AI chatbots? Yeah.
Um, I usually use Google. There are certain courses in certain LinkedIn and Coursera which can help on building this conversational AI. But generally, I try to do the research based on the papers that we have. It there is a website called Science Direct where you can find a lot of research that is happening on these particular modules. So I feel that Science Direct has a lot of details on how these technologies are getting emerged, how each piece is getting used. So we can go there, search for the materials, and then do it. but there are a lot of books and courses that we can do it. I really like this Andrew NG book. It gives an Andrew NG series on YouTube. On Coursera also he has an series where he explains different categories of an machine learning and how we can do machine learning. What are the different aspects that we should consider in a machine learning?
Amazing, amazing. Thank you for that. And everybody's loved the talk. So, Dr. Lakshmi herself is from VIT Bhopal University, and I would like to specially thank her at this time. More than 115 people had registered for it. 30% of them did show up right now, and I'm sure more will look at the recording later on. So, special thanks to VIT University Bhopal. And thank you so much, Sravanthi. This has been an amazing start to the weekend. I think a lot of us are going to go back to our books and uh, figure out
I
ways
hope.
to build chatbots.
I hope it
Thank you.
really
Thank you.
helped. Thank you.
Absolutely. Thank you so much. Thank you.
Thank you. Bye bye.